The fastest hero of all can never catch the slowest tortoise. It is an argument that has held up for 2,500 years. In Greek myth, Achilles, the fastest hero of all, runs a race against a tortoise. It would be far too unfair, so Achilles lets the tortoise start far out in front. The outcome is obvious. There is no way the far faster runner fails to catch a slow one with a head start. At the starting signal, Achilles breezes past him within seconds. Even a 5-year-old gives the same answer. And yet, about 2,500 years ago, one man came to the exact opposite conclusion. Far from overtaking the tortoise, Achilles can never even catch up to it. This is not, he misses by a hair. It is literally never, not ever. What is even more maddening is that you can follow the argument line by line and find nothing to object to. The man who left us this absurd claim is Zeno of Elea, a philosopher of ancient Greece. He was a philosopher, not a mathematician, and his teacher was Parmenides. Change and motion in the world are in truth an illusion. He is said to have devised his paradoxes to defend this idea of his teachers. Zeno's own book is lost, so we know his arguments only through later accounts, such as Aristotle's. The original version had no tortoise at all. The tortoise was slipped in much later, by someone dressing up the story. This video follows that argument step by step, and pinpoints exactly which word pulls the trick. Now let us follow Zeno's argument honestly, one step at a time. Achilles runs 10 meters per second, and in that same time the tortoise covers 1 meter, 1/10 as far. And at the start, the tortoise stands a full 100 meters ahead of Achilles. Achilles is giving him that head start. First, Achilles runs to the 100-meter mark where the tortoise began. In that time, the tortoise has crawled 10 meters further. When Achilles reaches that 110-meter mark, the tortoise is already at 111 meters, 1 meter ahead again. When Achilles arrives at 111 meters, the tortoise has moved another 0.1 meters ahead. Do you see it? Every time Achilles reaches the tortoise's spot, the tortoise has always moved a tiny bit further ahead. The gap between them shrinks to 1/10 of itself each time. 100 meters, 10, 1, then 0.1. But no matter how small it gets, the moment when that gap becomes 0 never arrives. So this chase repeats without end, and the points Achilles has to reach become infinitely many. Here are the actual numbers. The gap only shrinks, and the table never ends. And so Zeno concludes, Achilles can never catch the tortoise. In words alone, it's hard to put your finger on the flaw. So let's lay out where those checkpoints actually fall. The blue ticks on the distance axis are Achilles' checkpoints. They really do go on without end. To hear Zeno is right. There truly are infinitely many steps to pass through. But do those infinitely many ticks spread evenly across the whole track? They do not. The ticks crowd in tightly just short of a single point, the one marked by the orange dashed line. That point is 100 divided by the quantity 1 minus 0.1, that is 1000 divided by 9, about 111.11 meters. And right here is where Zeno's trap is hiding. Now let's dig out what this ancient trap really is. Zeno's argument rests on one hidden assumption he never says out loud. It looks so obvious that nobody ever questioned it. And it is false. The key to the trap is that the steps keep getting smaller. The distance left to close goes 100 meters, 10 meters, 1 meter, shrinking to 1/10 each time. So what happens if we add up every one of those distances? You'd expect it to grow without end. But add them up, and the sum stops dead at 111.11 meters. Look at the figure on the left. On top of a 100-meter slab we stack 10 meters, then 1 meter ever thinner slices forever. And still, the total height of the stack never breaks through the orange ceiling. The figure on the right tells the same story. Add just a few terms and the sum pins itself straight against the ceiling. Think of it as eating half a chocolate bar, then half of what's left, then half of that again. Repeat forever and you still only finish 1 bar, you never end up eating 2. That there are infinitely many pieces, and that their sum is infinite are two entirely different claims. In mathematics, when an infinite sum settles quietly onto a single value like this, we say it converges. When you keep multiplying the first term by a fixed ratio, the whole sum collapses into a single line, as long as that ratio is less than 1. In our race, the first term was 100 meters, and the ratio we kept multiplying by was 1/10. So Zeno's conclusion flips. Add up every one of those infinitely many steps and you get a mere 111.11 meters. Grade school arithmetic confirms the same answer. Achilles closes the gap by 9 meters every second. So closing a 100-meter gap takes 100 divided by 9, about 11.11 seconds. And in that time Achilles has run 1000 divided by 9, about 111.11 meters. As the code output shows, the infinitely split answer and the one-shot answer agree right down to the decimals. In fact, Zeno set the very same trap a second time in an even simpler form. This time we need no tortoise and no race. Just walk across a room to the door. To reach the door, you first have to cross half the distance to it, obviously. From there you have to cross half of what's left and then half of that again. There are infinitely many halves to cross, so by Zeno's logic we could never get out of the room. This one is called Zeno's dichotomy paradox. He also left us the arrow in the stadium. You can probably guess the answer already. Look at what those halves add up to. This infinite sum neither overshoots nor falls short. It stops at exactly one room's length. So we cross an infinity of steps and walk out the door just fine. Here it is in a picture. There are infinitely many colored pieces, yet they fit perfectly inside a bar of length 1. The partial sum counted piece by piece always falls short by exactly the piece you just crossed. Run the numbers and after just 8 pieces the distance left is 1/256. The distance covered approaches 1 but never passes it, while the distance left shrinks toward 0. If this formula feels unfamiliar, you have actually already met it back in school. That unsettling equation. Add 0.9, then 0.09, then 0.009 on and on forever, and you land on exactly 1. Far from trapping us in the room, the infinitely many halves carry us politely right up to the door. Fine, the distance is finite. But what about the time? If there are infinitely many steps to take, shouldn't it take infinitely long? Good question. Time meets exactly the same fate. The time for each step is its distance divided by the speed. 100 meters takes 10 seconds, 10 meters takes 1 second, 1 meter takes 0.1 seconds. These times form the same kind of shrinking sum. Add them all up and you get 100 divided by 9, about 11.11 seconds. Infinitely many steps, and yet every catch-up Zeno described is over before this single moment. Once 11.11 seconds have passed, Achilles has gone through all those infinite steps and pulls ahead of the tortoise. There is no contradiction in finishing infinitely many tasks in a finite time, as long as those tasks shrink fast enough. Hard to take in from words alone. The blog post has a demo you can click through yourself. Every time you press step, the gap between them shrinks by a factor of 10, and the ticks pile up densely just before the catch-up point. Change the tortoise's speed with the slider, and the catch-up point and its time move together. And press step a dozen or more times all the way to the end. A strange moment is waiting. The difference between the two positions becomes smaller than the smallest unit of a 64-bit floating point number. In mathematics, the gap never becomes 0, but a computer with finite resolution stops right there. So was Zeno simply wrong? Let's be honest and go through a few things. It would be easy to laugh at Zeno right about here. He didn't even know that much and still talked nonsense. But that is unfair to Zeno, and to the depth of this story. Let me make 3 points. First, we just breezed past the idea that an infinite sum can still be finite. But that was no cheap word game. It was a problem mathematics could not pin down rigorously for nearly 2,300 years. Archimedes in ancient Greece did manage to evaluate certain infinite sums. But the concept of the limit that holds it all up took shape only in the 19th century, with Cauchy and Weierstrass. So when we say just add them up and you get 111.11, all of 19th century analysis lies underneath. With a single footrace, Zeno pinpointed a question humanity could only answer 2,300 years later. Second, we should be clear about exactly what mathematics solved. The convergence of an infinite series clears away the arithmetic illusion that infinitely many steps must take an infinite distance and an infinite time. But philosophers push one step further. Can infinitely many actions really all be completed? This is called a supertask. There is still no consensus. No side can be declared the winner. And this tidy answer quietly assumes that space and time divide infinitely and smoothly. That is not a purely mathematical fact. It is a heavy assumption about the physical world. So here is where we land. The mathematical answer is perfectly correct within the domain of mathematics. But we won't flatten the philosophical resonance that remains beyond it. A great paradox leaves a deeper question open. In a 1929 essay, Borges wrote that this paradox had withstood refutation for more than 2,300 years. Lewis Carroll later borrowed the same two characters, but his is a paradox of logical inference, not of motion. We have come a long way. Let's sum up in one line where Zeno's trap goes wrong. He quietly assumed that if there are infinitely many steps to pass through, it must take an infinitely long distance in time. But if the steps shrink fast enough, infinitely many of them all finish within a finite distance. Achilles does not overtake the tortoise by dodging infinity. He overtakes it by passing straight through that infinity. The same goes for infinitely many moments. They all slip by in just over 11 seconds. So here is the lesson this ancient race leaves us. Infinity does not mean enormity. Which means this small infinity is hiding inside every casual step we take. Behind a fact obvious to a 5-year-old lay mathematics that humanity spent 2,000 years refining. The race between the fastest hero and the slowest tortoise turned out to be a story about how to tame infinity. If you enjoyed today's video, please subscribe, hit like, and turn on notifications. See you in the next story.